Now that we have a good understanding of how to name and write chemical formulas from topic 5, we're now going to move on to topic 6, which is looking at how the atoms are bonded together in what we call Lewis dot structures. In other words, we're going to be representing molecules in this topic here. To get started, let's first talk about a brief introduction about bonding. Reminder that atoms want to become like noble gases because the noble gas configurations is when the atom is most stable. This is where the Octet Rule comes from, which states that atoms will either gain, lose, or share electrons in order to achieve a noble gas configuration. For most noble gases, this means 8 valence electrons, with the exception of helium being 2 valence electrons. When an atom has 8 valence electrons, or a noble gas configuration, this is known as achieving the Octet Rule. So, atoms will bond together in order to achieve a full octet, which is a noble gas configuration. Reminder that atoms in molecular compounds or covalent compounds share electrons. If we take a moment to review what a covalent or molecular compound does when it bonds, let's take for instance the 2 fluorine atoms that we see. Fluorine has 7 valence electrons, which is shown. Recall that in a covalent compound or molecular compound, atoms will come together and share electrons to feel the full octet. So if these 2 fluorines were to come together and bond, we would see that they would share the 2 electrons that are in the middle. As a result of these 2 atoms coming together, the 2 electrons in the middle would be shared. This makes both fluorines feel as if they have 8 valence electrons. Now there's an easier way that we can show that these 2 electrons in the middle are shared, and that's by drawing it as a dash. A pair of shared electrons can be represented by either 2 dots as we see at the top, or with a dash, which is going to be the most common way that we show it at the bottom. There's also these electrons that are around the fluorines. These are called lone pairs. Lone pairs are unshared pair of electrons. Each fluorine has 3 lone pairs, for a total of 6 lone pairs represented in this particular fluorine molecule. Now, shared electrons between 2 atoms don't always have to be a single bond. Sometimes they could be multiple bonds. A single bond is what we saw before with fluorine, or in the case right here with the 2 hydrogens. A single bond is representing 2 electrons that are being shared between the 2 atoms. You can also have a double bond, which represents 4 electrons being shared, or you can have a triple bond, which represents 6 electrons being shared. We'll get to later in this topic how you can tell whether it will be a single bond, a double bond, or a triple bond. But for now, let's focus on the bond lengths and the bond strengths. If you were looking at a particular pair of elements that are bonded together, for example, let's take a look at the carbon-carbon bonds. When we take a look at 2 carbon atoms that are bonded together in a single bond, a double bond, and a triple bond, first notice the length. The single bond is the longest, while the triple bond is the shortest. So in a particular pair of elements, the triple bonds generally tend to be the shortest, and the single bonds are the longest. We can see that also, for example, down at the bottom here, with the 2 nitrogen-nitrogen single bond, the nitrogen-nitrogen double bond, and the nitrogen-nitrogen triple bond. The single bond is the longest, and the triple bond is the shortest. But in terms of their strength, we find that the single bond is the weakest, and the triple bond is the strongest. This is represented using bond dissociation energy, or sometimes we just say bond energy. The higher the energy, the more energy it takes to break that bond. So the fact that the carbon-carbon triple bond has an energy of about 812 versus the carbon-carbon single bond has an energy of only 331 indicates that the single bond is easier to break, meaning that it's weaker. That wraps up section 1. We'll see you in section 2.